The phytosaurs were semi-aquatic reptiles from the Triassic, the first period of the Mesozoic era. Although they could be easily mistaken for crocodilians, they were only distant relatives who converged upon a similar lifestyle as semi-aquatic predators. However, there was a phytosaur who diverged from this path. Named Nicrosaurus, it was far better suited for terrestrial locomotion than either crocodilians or other phytosaurs. With an estimated body length of 4 to 6 meters, Nicrosaurus may have been one of the top predators of its time. There are two species of this terrestrial phytosaur. The type species, Nicrosaurus kapfi, was found in 1861, but only recognized as a distinct genus 5 years later. The other species, Nicrosaurus myeri, was named in the year 2000. A phytosaur found in North America, Smiloseuchus gregorii, was once misclassified as a species of Nicrosaurus, but both valid species of Nicrosaurus have only been found in what is now Europe. The formations they are found in were formed about 215 to 212 million years ago, and were once a mixture of terrestrial environments and freshwater swamps. Although many of their similarities were the result of evolutionary convergence, phytosaurs and crocodilians both belong to the clade Archosauriformes. Archosauriformes were common during the Triassic period, although the most famous members of the clade, the dinosaurs, were still uncommon and nowhere near the size of their Jurassic and Cretaceous descendants. However, the sauropodomorph dinosaurs, like the contemporary Plateosaurus, were already some of the largest animals alive. Smaller Plateosaurus were likely common prey of Nicrosaurus, while the largest individuals would have been immune from attacks from this fake crocodile. On the other hand, the only contemporary predator that could match or exceed Nicrosaurus was not a dinosaur, but the 6-meter-long Rauisuchid Teratosaurus, who is ironically more closely related to crocodilians than Nicrosaurus was. Most Archosauriformes had straight, erect limbs. However, due to their similar lifestyles, the legs of most phytosaurs were built like those of crocodilians, with the legs splayed out to the sides in a sprawling or semi-erect posture. In contrast to other phytosaurs, the limbs of Nicrosaurus were longer, the femur was straighter, and the ilium had become less compressed. These traits are present in other terrestrial Archosauriforms, and it would have allowed this late Triassic carnivore to walk in a more erect gait. Extinct crocodilians who returned to a fully terrestrial existence, such as the Australian Quincana, evolved similar legs. However, although longer than those of other phytosaurs, Nicrosaurus's legs were still shorter than those of most of the other top Triassic predators. Rather than leaving the water completely, Nicrosaurus may have only been semi-terrestrial. The closest modern analog would be the Cuban crocodile, who is one of the most terrestrially adapted living crocodilians. Of course, it is also possible that Nicrosaurus's body had simply not completely caught up to its behavior yet. Like all phytosaurs, Nicrosaurus had a long, crocodile-like snout, which could grow 3/4 of a meter long. The skulls of both species were deeper than those of other phytosaurs. Such a deep skull was not as hydrodynamic, but it was sturdier and would have been able to support larger jaw muscles. Much like its long, straight legs, Nicrosaurus's deep skull mirrors those of the later land crocs. The depth of Nicrosaurus's skull was enhanced by the massive, bony crest that ran along its snout. The addition of soft tissue may have made it even larger in life. Other phytosaurs besides Nicrosaurus had cranial crests, which are thought to have been used to attract mates, much like similar crests in some dinosaurs like Guanlong. Male gharials have a large bump at the end of their noses, which may serve a similar function, but can also be used to attract potential mates with the unique sounds it makes. Nicrosaurus's crest may have also provided this secondary function, but like other phytosaurs, its nostrils were at the back of the snout, not the front as in crocodilians. Crocodilians have straight, conical teeth. Although they have more variation than the teeth of other extant reptiles, they all have a fairly similar shape. Nicrosaurus was instead heterodont, possessing multiple tooth shapes. The teeth at the tip of its snout were large, curved, conical, and fang-like. Behind them were 4 different types of teeth, some with tall, compressed forms, while others were similar to the conical teeth of crocodilians. Given the differences between its teeth, it has been hypothesized that Nicrosaurus utilized them to hunt different types of animals, with the long front teeth being adapted to catch small, swift creatures, while the back teeth were used to deal with larger, more difficult prey items. However, a study of phytosaur teeth found those of Nicrosaurus to all have similar microwear patterns, with the differences mainly being accounted for by the size of the teeth. More substantial differences would be expected if they were used to deal with different types of animals. A different hypothesis is that Nicrosaurus used its fang-like teeth for killing its prey and the rest for processing its meals. However, other terrestrial predatory Archosauriformes were able to eat just fine with just one type of tooth. The previously mentioned study of phytosaur teeth found the microwear left on Nicrosaurus's teeth to be consistent with that of both large terrestrial carnivores and fish eaters. This supports the idea that Nicrosaurus did not entirely leave the water, although whether or not it caught fish in the same manner as crocodilians and other phytosaurs is another question. The most terrestrial phytosaur after Nicrosaurus was Redondosaurus. Redondosaurus lived in the American Southwest at the very end of the Triassic period. It had a straight femur similar to that of Nicrosaurus, but its ilium resembled those of other phytosaurs, so it likely still spent more time in the water. Nicrosaurus and Redondosaurus both belong to a smaller clade within Phytosauria named Mystriosuchini. It was once hypothesized that the namesake of the clade, Mystriosuchus, may have been the female form of Nicrosaurus, since its skull lacked ornamentation. This hypothesis has been thoroughly debunked. Not only are the number of differences between them far greater than can be accounted for by sexual dimorphism, but a species of Mystriosuchus, Mystriosuchus westphali, has since been found with a bony crest. Nicrosaurus and Mystriosuchus were also as ecologically divergent as phytosaurs could be. Whereas the skull of Nicrosaurus was built to hunt large animals, the slender skull of Mystriosuchus was instead suited for hunting smaller, softer prey. Furthermore, while Nicrosaurus was the most terrestrial of the phytosaurs, Mystriosuchus had the most aquatic adaptations. Indeed, given how its fossils are found in what was once the deep ocean, it may have even been fully aquatic. A key difference between Nicrosaurus and the other contemporary terrestrial predators was its metabolism. Archosauriformes ancestrally had high metabolic rates, which allowed them to be more active than other reptiles. However, phytosaur metabolisms had become fairly low, a trait shared with the ecologically similar crocodilians of today. Although Nicrosaurus had become more like its terrestrial ancestors, it seems to have retained this low metabolism. Endotherms and ectotherms have different internal bone structures, and Nicrosaurus's bone histology isn't substantially different from that of other phytosaurs. Fortunately, although low by Archosauriform standards, phytosaur metabolisms were higher than those of crocodilians and most other ectotherms. Still, when on the hunt, Nicrosaurus would have had to use tactics more like those of the Komodo dragon or Cuban crocodile than a lion. Nevertheless, Nicrosaurus was one of the deadliest creatures of the late Triassic. With its greater terrestrial adaptations, it filled a unique niche among the phytosaurs. However, with its lower metabolism, combined with the possibility that it retained some of its ancestors' aquatic habits, Nicrosaurus didn't simply return to the same lifestyle as the terrestrial Archosauriformes, but filled a unique place among the diverse fauna of the late Triassic.
Thank you for watching, and a thank you to themattalorian for narrating this video. If you enjoyed it, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.